Okay, this is a video at National 5 level for volume. It's just the first video, so it's a wee introduction of things you have to know and the types of questions that come up. The next video I'll actually do different types of questions to show you the different types that can come up. So this is just a wee short video on the basics that you need to know for National 5. So, volume. So, a wee mind map, we'll do a wee mind map. And what do we have to know? Well, first thing you have to know, normally comes up paper 1, is very basic shapes, okay? So, basic shapes. Some formulas you'll need to know, some will be given in the exam. So I'll just detail all the ones that we need, okay? So, first volume shape I'm going to draw is a sphere. Sphere's a 3D circle if you like. So it looks like that. And to work out the volume of that sphere, so I call it a sphere, is a very straightforward equation. So volume equals 4/3 pi r cubed. Common mistake you see in exams, people put r squared, even though this formula is given in the exam. Remember to double check it. So this would be the centre, and the radius comes from the centre out to the circumference. So you only need to know the radius and you can work out the volume. So I've saw that quite a few times in paper 1, and it's a non-calculator, and you take pi 3.14 if it's a non-calculator. So that's the first shape. Next shape, we've got a cone. Cone looks like that. Again, the centre's here, and the vertical height, that's from the centre up to the point, that's the vertical height. And to work out the volume of a cone, V equals 1/3 pi r squared h. Next basic shape is a cylinder, closely related to the cone. So there's my cylinder. Again, we've got the radius out to the centre there, from the centre out, and V equals pi r squared h. So hopefully you see there the cone, just put cone, call that cone, and we call that a cylinder. I can spell it. Cylinder. Okay, so cone is 1/3 of what a cylinder is. Okay, the formula's almost the same, but it's only 1/3 for the cone because we've got less of it. Okay. Any other shapes? Well, if we've got a prism shape, now just going to draw a prism. Prisms come in all sorts of shapes, but for a prism, essentially what we have is we have the cross section. I'll show you what cross section is in a wee minute. This cross section here, and the volume for any prism, so we call this a prism, and the volume for a prism is the area times, in this case, the length of it, yeah, that's the length, times L. If it was standing tall, then it would be the height. So if it's lying down, then it's the length, or if it's standing on its edge up the way, it's AH, depending how it's lying. Okay, so if I maybe show you a cylinder for this. So if a cylinder is a prism, it's a circular prism. The area at the side is the same, that would be length. But if it's standing tall, just like this one over here, just draw it here, then it would be AH. And that's the difference between them. Now I said the cylinder is a prism, and it is, so see the circle part of it? So the A for the cylinder, the area is pi r squared, because there's the area at the side. So that's a cross-sectional area, we call that, and it's the height up the way, and this is the height going up. Okay, so this here and this here is the same if it's a cylinder. Now, you can get all sorts of other types of prisms. A common one to come up is a triangular prism, something like that. That's meant to go there. So the volume for that would be, here's a cross section here, so it's a triangle, so it's a half the base times the height and times the length for the volume. So length there, and again that would be this formula here, the area, this part here is the area, half the base times the height. Okay, sometimes here you'll be given a hemisphere. A hemisphere is half a sphere. So if we draw a semicircle, try and put a wee bit around that. That's meant to look like a hemisphere. And that volume would be a half of what a sphere is. So that would be a half 4/3 pi r cubed. Okay, and if you tidy that up, it turns out to be 2/3 pi r cubed, because half of 4/3 is 2/3. Okay, I think that's all the shapes really I can think of that tend to come up. There is, I'm sure there is other ones, but that's the sort of basic ones there. Okay, prism comes up a lot in these ones. Now, paper 2 type questions. Well, paper 2 type questions over this side are all related to these basic shapes, but they make it a wee bit harder. I mean, these questions here, you've got the formula, you just plug in numbers in it, and it's quite straightforward. But to make it a wee bit harder, so we'll say harder volume. Well, I'm going to split this into a few here. So first one we'll deal with is composite shapes. Composite question. That's when you get two basic shapes and you have to add them together. So let's see if we can draw something like that. So you might get say a rectangle, something like that. Okay, and you might get say a circle or a sphere, I should say, in the bottom of it. Okay, don't know, maybe that's some sort of trophy or something, so something daft like that. So you could get something like that. So that means you would have to find the volume of the cuboid, and then you'd have to find the volume of a sphere and add them together. I just thought of another one that's quite good. So there's the rectangle. Then you maybe get a semicircle on the top, semicircle on the top, and you've got to work that out. So that would be a rectangle, sorry, that would be the cuboid plus a semicircle, so half a circle times the length. Okay, so to do that type of question, this one, there's your cuboid plus your sphere. So you split them up and you do them individually. And again, this one here, so the volume for that, the total volume, volume 1 and volume 2, and you add them together to get a total. This one here, this is the prism. So you work that out, that's the top part of it, plus again the cuboid. Okay, as a composite one. Obviously these are different questions. So that's the volume for the total volume. Would be that plus that. Right, let's go down to here. Next type of question. Big volume minus small volume. Again, very common to come up. So the one I can always remember is having a cone. Here's a cone shape. Then you have a small cone. Yeah. And you're asked to work out this area in here. Okay, so you should be able to see the big cone here. Here's the centre of the big cone. There's the centre of the small cone, vertical height. So the volume for this one, total volume for this one would be the big cone, so you work that out. The formula for a cone's over there. And you get whatever that is minus the one for the small cone. So here's the small cone here. You take one away for the other. So a big volume, take away small volume. And that would give you your answer, whatever your answer is. Okay, so that's a type of question there. Big volume, take away small volume. Composite. These two things are very similar. For the composite, you're adding them together because you've got two different shapes. Work out each of them and add them together. For this one, you're working out one volume and you don't want this top volume here, so you're taking away the small volume. So you're working the two volumes out, but you're taking them away this time because you want this awkward looking shape in here, which would be hard to calculate. But because you've got a big cone and you don't want this small cone, take one away for that and you get this awkward shape. Again, very common to come up in that. Okay. Last type I can think about just now is working backwards. So working backwards. So we're working backwards. So how do we go about doing that? Well, you're normally given, again, but I'll pick a cylinder this time. So here's my cylinder. And this time you'll be given the volume. So you know the volume. And the volume for a cylinder is pi r squared h. So in this type of question, I'm working backwards, you're given the volume. So you'll be either asked to work out the radius or you'll be asked to work out the height. Now, to do that, you have to rearrange this equation. So let's work out the height for this one. So if I was asked to work out the height for this volume question, given the volume, so we'll tick to say we know the volume, we'll tick to say we know the radius. So if I have to work out the height, then I rearrange this. So this is another part of the course. This is changing the subject to the formula. So in this case, it's actually dead easy. So to rearrange that, swap it round. And we don't want pi r squared on this side, so we divide both sides by pi r squared, and we get h is equal to v over pi r squared. That's me dividing both sides by pi r squared. And we would work that out. Okay, so just remember, we're given the volume, given the radius, so that's how working backwards. This is definitely an A question, right? A type question. I'd also say big volume to get small volume is an A type question as well, so that's an A type question. And I would say the first question there up there, composite, is probably a C level question. Okay, I would say that's probably all you really need to know about volume for the exam. I suppose there is another one in terms of a pyramid. I haven't included it here. I don't think I've really saw it come up in the exam. Let's just put it in for clearness, a square based pyramid. So let me just bump it in here. So this is meant to be a square, and we've got a pyramid. Okay, so that will be the length, and that's the length. So for a pyramid, it's a third of the area times the height. Okay, for any pyramid, the volume for any pyramid here. Okay, square base pyramid there. So we can work that out. That'd be a third. Well, the area of the base here is L squared times H. So that's what we can do for that. But pyramids don't tend to come up very much at all. Okay, so I wouldn't worry too much about that. That type that definitely comes up, this type comes up, and all these definitely come up. And you're almost guaranteed in the exam to get one of these. Don't tend to get two of them, it's usually just one of these types. So you have to know the working backwards. Big volume to give a small volume, and the composite. Usually worth about 5 marks for the exam. Okay, so that's just a wee summary of what you need to know for volume. I will do a couple of questions in the next video, maybe take a couple of basics, might do a couple of basics in one slide, and then I'm going to do one of each of these, okay, to show you the idea behind it. Okay, that's the end of the video.